Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Selamat petang dan salam sejahtera. Hai semua para guru dan ibu bapa dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Akademi YouTuber, usaha sama e-didik dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Untuk mentambahkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan membaca doa mengikut agama masing-masing. Apa khabar para pelajar yang cikgu kasihi sekalian? Harap semuanya berada dalam keadaan sedia untuk meneruskan kelas kita pada petang ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas kita pada petang ini. Cikgu perkenalkan diri terlebih dahulu. Nama saya Teacher Tan dari Kolej Matrikulasi Selangor selaku moderator pada petang ini. Hari ini kita ada kelas tuition kimia pra-U. So pada petang ini kita bersiaran langsung dari channel Teacher Vivi Lau. Sesiapa yang belum subscribe Cikgu Vivi Lau, silalah tekan butang subscribe sebagai tanda sokongan kepada Cikgu Vivi Lau. Untuk makluman para pelajar, nama penuh beliau ialah Cikgu Lau Chai Wee dari Pusat Tingkatan 6 SMK Tinggi Kelang. Tajuk yang akan disampaikan oleh Teacher Lau pada petang ini ialah Electrochemistry, khas untuk pelajar matrikulasi dan STPM. Kelas ini akan berlangsung lebih kurang sejam. Bersama cikgu pada petang ini ialah Cikgu Kon selaku control host. Cikgu Kon adalah dari Kolej Matrikulasi Perak dan Cikgu Shannon merupakan ketua panitia pre-U kimia sebagai pemerhati kehormat. Sebelum kita teruskan kelas kita pada petang ini, ingin cikgu ingatkan semua pelajar dan para penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruang chat untuk menjawab soalan dan jika hendak mengajukan soalan. Pada akhir siaran ini, link e-sijil akan diberikan dan anda akan mempunyai 30 minit sahaja untuk mengisi maklumat. Pastikan anda menggunakan email e-didik sahaja. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar cemerlang dan marilah tunjukkan disiplin yang terbaik. Oleh itu, cikgu harap semua memberi sepenuh tumpuan pada kelas yang bersiaran pada petang ini. Tanpa membuang masa, cikgu serahkan kelas kepada Teacher Vivi Lau. Dipersilakan.
Thank you, Teacher Tan. Hi and good evening to all the teachers and students out there. Today we're going to learn about electrochemistry. Before I start the lesson, I'd like to thank Cikgu Shannon as the control host for today's live lesson. Cikgu Shannon is from Kolej Matrikulasi Pulau Pinang. And also thank you, Teacher Tang, as a moderator. She's from Kolej Matrikulasi Selangor. And last but not least, Teacher Kong. She's from Kolej Matrikulasi Perak. Okay, so let's look at the slide. So before I begin, I introduce myself first. So my full name is Lau Chai Wee. I'm teaching in Pusat Tingkatan 6 SMK Tinggi Kelang. My teaching experience is 19 years. Okay, my YouTube channel is Vivi Lau. Okay, so this is my PU team YouTube playlist. You can get a lot of videos from the playlist. So we have Mathematics T and Mathematics M, which is led by teacher Im. And we have teacher Eileen, teacher Zainaria. Then now we have new members. Okay, so you can visit the playlist to get their videos. And next we have biology PU team. So the ketua panitia is Cikgu Faiza and the members Cikgu Wawa, Cikgu Naini and Cikgu Fatia. Okay, then we have physics team. So this is a new team that can have live lesson, live class in the next week. I think. Okay, so the ketua panitia is Cikgu Osman. Yeah. Okay. Then we have accounts and economy teams. Okay, so Menam PT is the ketua panitia. So we have member Cikgu Yati, Cikgu Lee, and Cikgu E. So last but not least, we have chemistry team. So Cikgu Shano is our ketua panitia. We have teacher E, teacher Tang, teacher Cikgu Mawa, and teacher Kong. So let's begin our lesson. Okay, before that, this is a Porter Academy YouTuber. You can get the timetable for all the online classes here. Okay, so let's begin the lesson. So today we are going to learn about the electrochemistry. So the learning outcomes, we have students have to explain the redox processes and the cell diagram, also can call as cell notation of the Daniell cell. So student must know how to construct the redox equation, describe the standard hydrogen electrode, calculate the standard cell potential using the standard electropotential values, and write the redox equations, predict the power of oxidizing and reducing agents from the standard electropotential values, predict the feasibility of the reaction from the cell electropotential value, and from the combination of various electron potentials, such as spontaneous and non-spontaneous electron reactions. And finally, using the Nernst equation to calculate the non-standard cell potential. Okay, so let's begin. So first, let's look at half cells and redox equations. So half cell is defined as when the metal is in contact with a solution of its ions. So you can see here we have two half cells. So one is zinc half cell and another is copper. So you can see the zinc electrode, the metal deep in is a metal ion solution. So zinc half cell and the copper half cells. Then you have to know what is anode and cathode. So anode is the electrochemical cells. It's an electrode at which oxidation occurs. So today we only focus on electrochemical cells. Another cell is the electrolytic cells we will discuss next time. So to memorize this one, you can memorize the an oxide. So use the pneumonia. So an ox. So an ox. Okay, an ox. So an ox and not N stands for anode, then ox stands for oxidation. Then for the cathode, you memorize as red cat. Okay, will help you memorize. Okay, red cat. Okay, so vector is the electron average reduction occurs. So bracket. Okay, so next slide. Okay, then the reading on the wattmeter will give the standard electrode potential of the metal. So let's say for the zinc half cells, we have negative 0.76 watt. So this negative signs of the standard electrode potential signifies that zinc electrode acquires a negative charge. Okay, the electrode potential on the zinc electrode is more negative than the potential on the standard hydrogen electrode. And the zinc electrode, zinc is oxidized to form zinc ion. Okay, so oxidation occur here. So the zinc electrode is the anode. Okay, next we have copper half cell. So copper ion / copper half cell has a positive 0.34 watt values. So the positive sign of the standard electrode potential shows that copper electrode acquires a positive charge. So the electrode potential on the copper electrode is more positive than the potential on the standard hydrogen electrode. So at the copper electrode, copper is reduced to the copper metal. Okay, copper ion here. So here should have copper ion. Copper 2 ion. Copper 2 ion is reduced to form copper metal. Okay. So you have to write the half cell equation. At the anode we have zinc oxidized to zinc 2 positive. So zinc will donate 2 electron. Cathode we have copper 2 ion accept 2 electron and form the copper solid. So when you total up the two half cells, you will get zinc plus copper 2 ion produce a zinc ion plus copper. So you must remember always write the physical state. So this is called redox equation. Must write the physical states for all the species are in the equation, and also in the diagram shows the concentration of the solution. Okay? So this one didn't show. So you have to show zinc ion. Okay, zinc ion. Okay, so zinc ion is A2. So always show the concentration. So you show 1.0 mole per dm². Okay. Oh yeah, the pen is too sensitive. Okay, 1.0 more to the input. So here also show copper 2 ion 1.0 more to the input. Okay. So we have salt bit here. Okay, next we have to write the cell notation or cell diagram. So always write the oxidation first. So zinc half cell right first. So always write the physical state. So negative AH hot oxidation here. Then the two lines here means the salt bridge. Okay, followed by the positive AH hot cathode where the reduction occurs. So the electrons falls from the anode to the cathode. Okay. So we call this ABC rule. Means you show the anode first, followed by bridge, so bridge, then C is stand for cathode. Okay. Then you will not make mistake. So ABC rule. So show the physical state also. Okay, then okay, the how to remove this? Okay, so no, okay. So the concentration can show at the side here. Okay, 1.0. Okay. Okay, so for cell diagram, don't show the concentration also. Okay, show beside the aqueous ion. Okay, the function of the sorbate. Function of the sorbate containing an electrolyte. Sorbate is containing an inert electrolyte solutions, or we say saturated solution. So it will not react with the ions in the electrolyte. The example of the solution electrolytes here is the potassium chloride or potassium nitrate. So the function is to complete the electrical circuit of two half cells, allow the movements of cations and anions between the two solutions. So this is sorbate. Okay, next we have definition of the standard electrode potential. So the standard electrode potential is the potential acquired when the metal is immersed in a 1.0 mole per cube solution of its ions at a temperature of 25 degrees Celsius. So you have to state the standard condition. Okay. So we use this one to measure the ability of the half cell to attract electrons at the standard conditions. So means more positive electron potential value, it will have higher ability to attract the electrons. Okay, so the standard condition you must state out. So we have temperature 25 degrees Celsius is also known as 298 Kelvin. Then the pressure is 1.0 atmosphere, and the concentration is 1.0 mole per cube for the standard one. So more positive half cells will have greater ability to attract electrons, so will act as a cathode. Okay, then you also need to know the standard halogen electrode definition. So the standard electrode potential for halogen electrode is defined as 0.00 volt. So this is a set of standard halogen electrode. So where the halogen gas is connected to the electrolytes, which is a dilute acid, with 1.0 mole per cube. Okay. Then the electrode here is platinum. Okay, next we have, okay, so we use a standard halogen electrode to determine the standard electrode potential of the cell. Since the electrode potential of halogen is 0.00 volt, so straight away from the voltmeter reading, you can get the standard electrode potential for the metals. Okay, so the standard electrode potential of metal is the potential difference between the metal and a 1.00 mole per cube aqueous solution of its ion, measured relative to a standard halogen electrode. So you have to know how to roll this. Okay? So again, must mention the concentration. Remember to mention the concentration. Physical state also must write. Okay, in the library, and also mention the standard condition. Okay. So next one is to calculate the cell potential and write the redox equation. Okay, so again, half cell with higher negative charge, sorry, not higher negative charge, higher negative potential, electron potential, or lower positive electron potential will undergo oxidation. However, for half cell with lower negative or higher positive electron potential will undergo reductions. Okay, so the formula is for the cell electron potential is equal to the electron potential of the cathode minus the electron potential of the anode. Okay, or you can write reduction half cell potential minus the oxidation half cell potential. Okay, so we also can predict the spontaneity or feasibility of the redox reaction from the calculated cell potential. Okay, so you calculate, after you calculate the cell potential, you can determine whether the reaction is feasible or not based on the charge of the cell potential. So if it's positive, then it's a spontaneous reaction. If it's a negative value, so it will be non-spontaneous reaction. Okay, so spontaneous means it will occur without heating. Okay. So let's look at the first question. Question 1. Calculate the standard cell potential for the electrochemical cells consisting of zinc ion and zinc and silver half cells. Predict the spontaneity of the reactions. Okay, so based on the formula, this one, electron potential, cell electron potential equal to cathode minus anode. No? So how to know which is cathode, which is anode? Look at the value of the electron potential. More positive will be cathode. Okay, more negative will be anode. So, or more positive or less negative. Okay, cathode. Then more negative or less positive is the anode. So student, try first. Any
Okay,
answer?
student, you can try, student, write on checkbox. Do you have any clue, teacher Vivi Lau? Clue
Yeah,
to the
so
student.
the formula, huh? Okay, so the formula is for the cell potential formula. Okay, so you take the cathode minus the potential of anode. Okay. So how to know it's cathode or anode? So you see and look at the value. So more positive will be cathode. Okay. So we have zinc and zinc silver. So this one more positive, so this one is cathode. Then zinc is more negative, so it's an anode. Okay. Or you can write here.
See, from Mi Fen Chong. E cell, E not cell equal to positive 1.56 volt. The reaction
1.5.
occurs spontaneously.
Okay, very good. So we look at the answer. So we use formula method. Okay, so positive 1.56 very good. So remember to show the formula. Normally formula will have marks. Okay, formula or substitution will have marks. Okay, depends on the question. So always show the formula first, then substitution. Must copy everything from the question. So must show the sign. So you cannot just write 0.80 here. Must write positive 0.80 minus bracket minus again. If you didn't write minus, no marks. So must show minus, show negative minus negative 0.76. So the final answer must show the sign also and show the unit. Show the unit board. Okay. So the reaction is positive value. So it's a spontaneous reaction. Okay, very good. Now we look at, so this is formula method. Look at the next question. So you have to write out the redox equation. So write out the redox equation. Zinc plus 2 silver ion from zinc ion plus 2 silver. So this one you based on the half cell first. So half cell is okay. So half cell silver plus neutral and zinc. So we need to times 2. Okay. So total up you will get this one. Okay, zinc plus 2 silver ion from the zinc ion plus 2 silver. Okay, so must multiply balance the electron. Okay, any question from the student?
No.
No. Okay, so we look at also question 1. Second. So now we have zinc and cadmium. So student, please try again for this question. Okay, any answer?
Not yet. Okay, the question is calculate the standard cell potential in a cell for the electrochemical cell consisting of zinc and cadmium. Zinc and cadmium.
Yeah, zinc and cadmium. So both are
Okay,
negative.
I think we have a
Okay,
answer now. Tanesh Rao. E cell equal to positive 0.36 volt.
Okay, positive. Okay, so let's look at the answer. Okay, so you can see here, so this one is more negative, so this one oxidation. Okay, okay. So this one less negative will become cathode. Okay, so negative 0.40 minus and minus negative minus negative 0.76. Okay, then you get the positive 0.36 volt. Very good. So the reaction is spontaneous reaction since the cell potential is positive. Okay, so the redox equation. So so you will have 1 mole to 1 mole because both same section. Okay. So no need to balance the reaction or balance. Okay, so now we look at second method. This one is formula method. Second method to calculate the cell potential. So by writing the equation. Okay, so you write out the equation. Okay, so from the value you can see here, this one and this one. So this is more positive, so this is cathode. Okay, cathode. Then this one is anode. Okay, so chlorine will receive electron reduction, then the iodide ion will oxidize. Okay, so you have to reverse the sign. Okay, so for equation method, okay, so when you reverse the equation, the sign of the electron potential also have to reverse. So from positive 0.45 become negative 0.54. Okay, so after that you total up the equation and the electron potential value, you will get the cell electron potential. Okay, so total up the equation, cancel off the electron. Okay, so the answer is 0.82 watt.
Teacher Lau, maybe we
Okay.
take a break first. We
Okay.
take a break.
Okay.
Berikutan pengumuman penutupan sekolah sehingga akhir persekolahan, pengajaran dan pembelajaran secara home-based learning tetap diteruskan. Oleh itu, kami di Akademi YouTuber menyediakan tuition online percuma pertama di Malaysia dari prasekolah hinggalah ke sekolah menengah dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. Kenapa bayar jika anda boleh dapat percuma? Bermula percuma, selamanya akan percuma. Manfaatkan peluang yang ada. Jangan tunggu lagi, startilah sekarang. Untuk maklumat lanjut, layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay. Okay, let's continue. Okay. So, question number 2. The cell diagram for a galvanic cell is shown below. Okay. So, ions half cell and hydrogen half cell. So, which segment is water half cell? Okay. Value acid half cell. Okay. Which segment is true about the cell? Okay, so this one got mistake. Okay, so student, you choose write your answer in the chat box.
Okay, student, we are given a cell notation. This is what we call
The
cell
cell
notation.
notation.
Okay. Still no answer from the student.
I think so. This one is wrong. Okay. H2. Okay. You try again, student. Sorry for a mistake. So hydrogen, yes, no, oxygen.
Okay, answer from Tanesh Rao again. B.
Okay.
He answered
B.
B.
Okay. Any other answer?
Not yet.
So again, here is hydrogen gas, no oxygen.
And also from me,
Yeah,
Fain Song, also B.
B, B or
Uh,
D.
B,
This should
B.
be B.
Ball.
Okay. Wrong. Any more answer?
Not yet. Teacher Tang want to say anything? Teacher Tang
To be
or Teacher Kong?
No comment.
No comment.
forgot to give you
Maybe teacher Vivi Lau,
potential.
you can give them the SRP value, the standard reductions
I
potential
I
value
forgot to give them the
for the two
value.
half cell.
Wait first,
Yeah.
okay, I'll give you the value. Okay, looking for the value.
Yeah,
Yeah.
Forgot to give the value. Hold
Yeah, yeah. Because to calculate the EMF,
because we need
they
the
need
value.
that.
Okay.
yeah,
So because
Yep.
because I find the value. Yeah.
And this one, Ani
Um,
Zahira,
for
answer
answer
A.
Anis Zahira.
A. Okay.
Ani Zahira.
So the value yes,
Tanesro change the answer A.
Yeah,
okay. So the answer is A correct. Okay.
yeah,
So the answer is A. Okay. The answer is A. Okay, so the electrical potential okay. Okay. Sorry, I forgot to share the electrical potential value with you. But the answer is positive. Okay. This one 0.0. Huh? Okay, so this one remember this is negative. Okay, oxidation rate. So negative after you uh remember the value is like this, cell equal to E cathode minus okay, so the E cathode minus the E anode. Okay, so for the Fe is negative, so negative this one positive. Cathode is zero, because it's hydrogen, so zero. So zero negative negative will become positive. Okay, so for the A is positive. Okay, then for the B is wrong because iron 2 plus you know is a green color. So this one should be green color. Okay, then C. So hydrogen ion is reduced to hydrogen gas. Okay, so the concentration should be decreased. Okay, then electrons fall from the platinum electrode to the N electrode, so it's wrong. So oxidation here, right, anode first, right, then cathode ABC one. So means the electron falls from the anode to the cathode. So electrons must fall from the iron half cell to the hydrogen half cells. Okay, so the answer is A. Okay, so we look at the next question. Okay, so next we have to learn the reducing and oxidizing agent. So reducing agents is undergo, it will reduce others, okay, means it's agent to reduce others, then it itself will undergo oxidation, so it will donate electrons. Okay, oxidizing agent means the agent that oxidize others or other species. So it itself will undergo reduction, so it will accept electrons. Okay, so we look at this example. Okay, so the itself here is very negative, so means the equilibrium position will rise to the right or left, to the left hand, okay, rise to the left hand. There is a strong tendency for potassium to form potassium ions, so the potassium ion predominates. Okay, potassium is a strong reducing agent. Okay, then we have chlorine. So you can see it's very positive. Okay, so it's a cathode. So undergo reduction. So the equilibrium position will rise to the right. Okay, reduction. So there's a strong tendency for chlorine to form chloride ion. So the chloride ion will predominate. Chlorine is a strong oxidizing agent. Okay. So let's look at question number 3. So based on the following half cell equations, arrange them in the order of increasing strength as, so increasing, okay, strength as a reducing and oxidizing agent. So you look at the signs. Okay, so students, let's try this one. So you can write for reducing first, then followed by oxidizing. So show the increasing strength, so means from lowest to highest. Okay, any answer?
Teacher Vivi, maybe you can give them hints which one is reducing agent, which one is oxidizing agent. Maybe you can
Hints,
give the
okay.
hints.
Okay, so again, reducing means undergo oxidation because it reduce other people, reduce other agent of reducing. So means it undergo oxidation, so means more negative one will undergo oxidation. So you look at the value, more negative one. So this one is more negative will undergo oxidation. It's a reducing agent. Then oxidizing agent, it oxidize others. So it itself will undergo reduction. So means more positive one undergo reduction. Okay. So this one more negative, or we can say less positive. More negative, less positive. This one more positive or less negative. Undergo reduction. So this one means the self oxidation.
Teacher Vivi Lau, the Tanesh gave the answer.
Okay.
Chromium is the strongest, followed by lead, and then the weakest one is silver as the reducing agent. Chromium, lead, silver. Chromium is the strongest.
Okay. So for the oxidizing agent,
For oxidizing agent, Chon, she gave the answer. The oxidizing agent is lead, followed by chromium, then silver.
Right, followed by chromium, then silver. Okay. So we look at the answer.
Yeah. Tanesh gave. Yeah, Tanesh also give the answer, and Anis gave the answer reducing agent from chromium, lead to silver.
Okay, so very good. So you can see your answer for chromium, lead, silver. So for oxidizing agent, more positive one. So more positive one, we have silver. Okay, so silver ion is the highest oxidizing agent, strongest oxidizing agent, followed by less positive 0.13. So lead 2 ion. Then chromium ion is uh, negative 0.74, right? Very less positive. So is the least oxidizing agent. Okay. Then for the reducing agents, must look at more negative one. So more negative one is the 0.74 common. So this one is the strongest reducing agent, followed by lead. Okay. Then last one is silver. So for the reducing agent, you must look at the uh, right side of the equation. Okay. Look at the right side for the reducing agent. Then for the oxidizing agent, you have to look at the left side of the equation. Okay, so you don't make mistake. Remember this one. Okay, undergo oxidation, right? So the right side will donate H1. Okay, then this one oxidizing agent is accept H1, so must be at the left side. Left side of the equation. Left side. Okay, so accept H1. Okay. Okay, very good. We look at the next slide. So summary, the more positive electron potential is, the greater the tendency for the substance to be reduced. So left side of the equation. So the substance is a strong then reducing agent. Strong oxidizing agent. Okay, example this one, chlorine plus 2 electron come to correct. Then the more negative the electron potential is, the greater tendency the right side of the equation to be oxidized. The substance is a strong reducing agent. For example, the potassium metal, then more negative, so it will donate electron. Okay. So for today, Nernst equation. So we see the what is Nernst equation or not. Okay. So the Nernst equation is to help us determine the electron potential under non-standard conditions. Okay, so example, the formula. Okay, so the electron potential equal to the standard condition, standard electron potential minus LT over NF times the natural long reduced form divided by the oxidized form. Okay. Okay, so if you substitute the value of the into the equation, okay, let's say for standard condition at 25 degrees Celsius, okay, 8.31 this constant, and the Polaris constant 96500, you will get another formula. Okay, E equal to standard electron potential minus the 0.0592 divided by N times log reduced form over oxidized form. So this is a Nernst equation. Okay, so normally you just memorize this one, 0.0592 divided by n. So n is stands for the number of moles of electron involved. So example, this question. Calculate the electron potentials for the following half cells at 298 Kelvin, but non-standard condition, not 1.0 mole per liter. So it's 1.5 mole per liter. So you use this formula, this formula to calculate. You copy down the formula to answer this question. Silver, the E cell I need to give you one, so it's positive. Standard E cell for standard electron potential for silver is positive 0.80. I must give you this only, you can calculate. Okay, positive 0.80. Okay, try to answer this one, students. Okay, any answer from the students?
No answer yet.
You can remember the formula and go back to the previous slide. So you use this one. So silver, you will get silver ion, another color. Silver ion plus electron from the silver solid. So remember you learned in sem 1, the silver solid is concentration is constant, so we don't need to consider the silver solid concentration. Okay, so product. So reduced form is the product. Products over reactants. So this one is constant, so means there is 1. So concentration of silver is constant, so 1. So xy also 1. So just now the standard potential for silver is 0.80. So any answer from the student? Any answer from?
No answer yet.
You look at this equation. So concentration of solid is constant. So means here the silver one is constant. The solid. So you can ignore. So you can carry one.
Teacher Vivi Lau,
Yeah.
the students say can flip to the next slide. They want to see the question.
I forgot to give 1.5. So the concentration of silver is 1.5 sensitive impact. One point five more per liter. So 1-800. Okay. Okay, any answer from student?
Not yet, not yet.
Okay, and show the answer. Okay, so
Okay,
Okay.
we got one answer from Tanesh
uh,
Rao.
Anita. What's the answer?
0.7408.
0.74.
Hmm.
Okay, 0.074. Okay, so 0.74. Okay, so here I use 0.059.
0.74.
Okay. So if you use 0.059, you'll get 0.81. I think if you get this 0.0592 around this answer. Anyone for 0.81 answer?
No.
Okay, so let's see if use 0.0592.
Uh, Teacher Vivi Lau, Tanesh has a question. He
I,
asked, for solid, should we use the concentrations as zero?
oh, cannot be zero. Concentration constant, it will become one. No, it will not become zero. Okay,
Oh,
so it will become one. So the concentration of the solid is constant, right? So it's a one. It's not zero. Okay. Then we do it for the equilibrium constant. So the concentration of the solid is constant. So uh, we ignore it, but we have to consider it's one. Okay, I look at the next one. Okay, so for the next equation, also to determine the cell potential. Okay, so if you want to calculate the new cell potential, you also use the same formula. So the cell electron potential and standard electron potential of the cell minus 0.0592 divided by n times log p. So you memorize this one, or you can memorize this one. Log product is concentration divided by
Vivi
reactants.
Lau,
Yes.
time's up.
Sorry. Okay. So
Oh,
I show
We have
one
5 seconds left.
5 seconds.
Okay.
Okay. So I end the lesson for today. So I will upload the PowerPoint into the YouTube channel. Okay. So you can see the the other parts of the lesson. Okay. Thank you, guys.
Okay. Okay. Terima kasih diucapkan kepada Teacher Vivi Lau atas perkongsian ilmu yang sangat bermanfaat. So, selesailah kelas kita pada petang ini. Tahniah diucapkan kepada semua pelajar yang mengikuti kelas dari awal saat akhir. Sebelum kita tamat sesi siaran langsung kita pada hari ini, mohon tutup ruangan chat dan klik button subscribe. Sekiranya anda suka dengan apa yang dipelajari pada hari ini, sila klik like and share kepada rakan-rakan di media sosial. Link sijil boleh didapati pada bahagian chat. Sila ambil perhatian. Link tersebut akan tamat dalam tempoh 30 minit selepas live ini. So sampai pukul 5 sahaja. So pastikan anda menggunakan email e-didik sahaja. So kelas seterusnya untuk tuition kimia Prayu adalah pada hari dan waktu yang sama minggu hadapan. So jangan lupa untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com. So access code untuk link sijil #kelas IU didik semua huruf besar. Sekali lagi #kelas IU didik huruf besar semua. So jangan lupa. So terima kasih kepada semua. So di siaran lain kita berjumpa lagi. Bye.
Tahukah anda tuition online percuma? Ya, pertama di Malaysia. Gandingan para guru menghasilkan yang terbaik, memenuhi keperluan pembelajaran anda. Semua mata pelajaran percuma. Dibawakan kepada anda oleh Akademi YouTuber Malaysia, Inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tahniah, terima kasih.
Dibawakan kepada anda oleh Akademi YouTuber.